Welcome back, friends. What I hear, I forget. What I see, I remember. What I do, I understand. Hands-on experience complements bookish knowledge, giving it the dimension of practical relevance and hence a deeper understanding. Needless to say, Sri Sathya Sai Vidyavahini has made significant strides to address this learning space too. With an eye for technology, Sri T. Sridhar masterminded the Experiential Learning Center, the STEM, where science, technology, engineering and mathematics related working models are on display and can be operated via apps. Students can now see the concepts and theories from the pages of their textbooks actually coming alive. To know more about this technological marvel, let's now invite Sri T. Sridhar, our STEM advisor, and Commander Balakrishnan, our STEM coordinator.
Sai Ram, salutations at the divine lotus feet of our Lord and Master Bhagavan Sri Sathya Sai Baba. Tell me and I forget. Teach me, I may remember. Involve me and I will learn for life. Was this told by Benjamin Franklin? I'm not sure. Some people say this is told by Confucius. There's a confusion there. But the underlying principle is that if you involve the students in what they are learning, it's going to stand them in good stead for a long, long time in their life. Now, what are the fundamental experiences that we go through every day? Pressure. We all talk about peer pressure, parental pressure, societal pressure. I don't mean that pressure. The pressure that I am talking about is the atmospheric pressure or hydraulic pressure, etc. The physical entity called pressure. There is another experience called temperature. Those who climbed up the steps this afternoon must have experienced temperature. And you came inside the auditorium, you felt a different temperature. So there's another experience that we go through every day. Distance. This is another dimension, experience. We have light and color. Professor Indu Kumar mentioned about, she showed a short video wherein a child sees colorful leaves and flowers, etc. What does this light, the color embody? It's basically light. So there are a lot of experiences that we go through in life, which we can relate to in every walk of life. Sridhar Thiruvenkatam, who is a robotics expert from IIT Madras, has a passion on electronics. So besides being CEO of several companies, he has developed a passion on developing electronics, and then he has married these electronics with these fundamental experiences that I talked about. So anything that you teach children, you can bring in these devices to produce analogous or digital experiences. And principles which otherwise would be difficult to communicate or emboss in their minds can be easily crystallized with the help of these devices. With the approval of the director of Sri Sathya Sai Vidyavahini, last year we conceived what is known as Experiential Learning Center. So Brother Sridhar has put together a certain set of experiential learning devices cutting across biology, physics, chemistry, and mathematics from 6th standard to 10th standard. And these are the very fundamental building blocks which can be used for any control devices also in automation terms. Similarly, they can be used for Internet of Things also. So it is basically the same simple electronic devices intelligently put together, which can be used for teaching purpose also, or for technological advancement also. So let me turn the floor over to Brother Sridhar to take you through the nitty-gritties of how he masterminded these devices and put them together in a short span of 4 to 5 months. 4 to 5 months in a very cost-effective manner. Over to Brother Sridhar. Sai Ram.
Loving pranams to Bhagwan's lotus feet. Good afternoon, everyone. So, as Balakrishnan brother said, we will get a feel of what's going to happen with the experiential learning. We have 85 slides to cover. I'm just joking with you. We have 10 minutes. We'll try and make it as simple and short as possible. The theme of this presentation is not to teach anybody technology here. The theme of this presentation, in brief, is to tell you how you can use technology to teach the things that all of you teach in front of your children in school. That, I think, is the basis premise on which you should start. There's no technology involved. The technology is behind this, and we are here to help you with the technology. What you teach is what you will teach in a normal day. It is just an enhancement aid. With that, let me take you over to the slides. So this is about classes 6 to 12, and lower than 6 if needed. And it's completely aligned to the CBSE syllabus. It was a brainchild of something that we created with doing gap analysis with school teachers who had a problem of having to teach to students, and the gap was the highest. In certain topics, they said, I teach every day, I do my best effort to put in the concept of science, but it's not reaching the desired children's level of competence that should be. And so we started off with that to make sure that we have a solid base of not having to teach something which is already easy to teach, but really the ones where the concept is difficult to teach. And that's where we started with the Experiential Learning Center. It covers, as Balakrishnan said, it covers general science, biology, physics, chemistry, and all the science subjects. So that's why it's called STEM, if you will. The attempt of this is to bridge what the school books don't cover. It's 2 dimensions, it's written, there's so much you can do with print, right? There's certain things you cannot actually make happen, and you have to see it happen. So that's, I think, the most important thing that the experiential learning. So the word experiential is about making you feel. Right now, what I'm doing is not experiential, right? I'm talking about something on slides, which I don't think is making a lot of sense. So we love for you to come to the evening and experience the Experiential Center live at the Vidyavani Center, right where the registration was done. There's a room. We will be available this evening for you to come and have a look at it. So the proof of the pudding is actually for you to come to have a look at it and experience it rather than me making the slides. But without much ado, I will get into the details. It's about the documentation available. The multimedia team has done a wonderful job about whatever experiments we have made experiential are available on print media, and it's downloadable using QR code. So true to being technologists, we also want you to scan your QR code and download the thing and take out rather than having to take reams of paper with back to you on the Experiential Center. It's developed in-house, which means that everything was built from scratch here. So no big licensing fees to pay. It is all assets that we built for Bhagwan. So it's available free. The assets are available free, and it doesn't cost us, as Balakrishnan brother said. The cost effectiveness, being easy to implement, being easy to maintain, and not leaving a burden of technology on the people who use this, were the mantra behind what we did with this, right? Now, this is simply the architecture behind it. I won't take too much time to try and explain this to you. At the bottom of this, what you see is the science that you teach. When I talk about science that you teach, it's about, just take the example, a temperature sensor, an anemometer, EMI, and a magnet moving in a coil where a current is being measured. These are all the sensors that you will teach in science in various classes from 6 to 12, correct? What we do is we try and take that data that is available on a live scenario, digitize the data, make it available on a Wi-Fi platform, and the third platform on top is the visualization platform. The visualization platform doesn't force you to stand in front of a PowerPoint presentation like this or a screen. You can see it on a phone, you can see it on the cloud, you can see it remotely, you can see the results of the demonstration in any medium which has a visual media. That's about it. The fourth layer is the cloud access. What it means is, as I mentioned, we like to make it as maintainable as possible, and we like to not have to come to visit the school or the place that you have put this together, and to be able to remotely connect to it and give you the latest version of the software. So the cloud maintenance is to internet connectivity essentially is for that, to make sure that you have access, we have access to it, and can maintain it and troubleshoot it for you without we having to come and do this on site and waste additional time. That, I think, is simply put the architecture behind this. Now, just to reiterate some of the points I just have already mentioned, this is small enough for all of you to carry it in a 29 by 29 suitcase, as simple as that. All the experiments that we have today, which you will have an opportunity to see, is in a suitcase. Balakrishnan brother, we put this together in Chennai, and he took an overnight train with a suitcase, and we were able to implement it. And I actually was not there for the first implementation at all, so we were able to plug and play this as easily as that. So to me, for all of you who are looking to do this, it's simple, small, and can be carried easily. And the fact that it doesn't have to be in a static place like a lab, you're not looking for a very large space, you're looking for a small room, or you can carry it to the class and actually showcase it when you're teaching that particular topic to the children. It is low-end. We assemble everything by hand here. We don't buy any high-end components. If interested, we'll give you a cheat sheet on how much it costs. It is definitely not the cost base of anything that people are now selling in the market about experiential labs. It's much more cost-effective, and we can discuss the details on how much infrastructure you have. It doesn't need the cloud. It doesn't need internet connectivity. You may be in a remote place where you want to install this, absolutely fine. All we need is a Wi-Fi router. It will be self-contained. It will work. Internet connectivity is only needed if we have to maintain this remotely from somewhere like us. That's, I think, an important point to mention. It's absolutely safe, which means it operates on a cell phone charger, as simple as that. So you're not touching any 220-volt power and all that. So as a point of reference, everything runs off 5 volts, which is like the mobile charger that you use day in and day out. That's, I think, an important point to mention. A simple example of this, how many of you have heard about something called an anemometer? No? Anemometer is wind direction, speed of wind in a location, right? It's a science concept. It's being taught in science. And this is a simple example of an anemometer's data. The right-hand side is the anemometer. The data shows up on the screen, and you will see the live data of what the wind speed at this point in time is, and the historical data on the second part of the screen shows what the wind speed was. All weather stations will have the anemometer and tell you what the wind speed is. A simple example of this also is a biology, botany example, wherein you teach about soil moisture and to children in various classes, soil moisture content. Now, if you want, it's very difficult to talk about soil moisture and not take them and tell them what soil moisture is. This experiment comes to the classroom wherein you can actually measure the soil moisture content in a sample and show that on a screen. Now, as Balakrishnan mentioned, the real-life enhancement to this, wherein people take this experience, or real-life experience would be where we apply this in the school's garden and put these sensors and have the data ready for us to automate whether you want to run a motor and a drip irrigation on it or not. Which means that the learning of science using this technology now enhances the children's ability to be able to experience what that science taught them to a real-life experience of, oh, this is how I can tend my garden in the school, or manage the kitchen garden at home without having to pour water when the plants don't need the water. That, I think, is a good example of enhancing this learning in science to the next level of being able to make a commercial product or a product useful for an industry or the agricultural world that we are in. Now, I'm 12 minutes over, and that's the time limit I have, and this is the last slide, so don't worry about it. So this is just the starting of what I think is an exciting set of opportunities. As you all know, we are the newest kids in the block because we started this last year. We were post-COVID, and we started this last year. We were able to get this. You will get to see more and more of this, and you can extend this to colleges. You can extend this to let's say you find 6 or 7 kids in the class or 10 kids in the class who are really interested in taking this forward. The technology and the architecture that we have does provide you the opportunity for you to assemble it yourself. It's not that we have to assemble it and give it to you and use it as an experiment, which is always available, but you can always make it happen by the children in the school, and actually they can put it together using do-it-yourself kits and really experience how all of this comes together. And that's something is very important. And so that's something that we are working on to make it happen. It's already there. We'll have to get the kits across for many of these things to happen. Now, the real next steps to this, since the time we envisaged this and took it to the next level, we have also come across feedback from the primary school here and other schools that talked about, these are all fine, but I love to have basic mathematic models. Basic models that are not electronics related, digital related, but things that I can take to class. And today, you will have the opportunity, if you come this evening, to be able to see 3D models of 2D things that are in print in classrooms that you can see and feel. Let's say you cut a cone in the center, what is the cross-section of the cone and how it looks, right? Area of a circle, area of a square, and things like that are available as models for you to carry to class and showcase them. So in a way, to teachers, instead of taking the book back with you to the classroom, we would like to carry these kits with you to the classroom, connect on Wi-Fi, and show these models to children. And I think the experience of having to show them will be a lot more invigorating for the children and make them think more. I think it's an important step forward. As I said in the beginning, it's not about teaching technology to children. We are talking about teaching science to children and enhancing your ability to be able to teach science better and probably get across the children better using the technology as a basis. That I think is important. Now, it's very, very important for you to understand, and I'll show this in the next slide, it takes 2 minutes, how your participation in telling us the importance of what I think is your gap that you are not able to achieve with the children is conveyed back to us so that we can build the solutions to this. And I just want you to see this 30-second video so that you can have a look at it. If somebody can play that, I have no idea how to play this. Yeah. Just listen to this for a second. And I'm not asking you a quiz question here and what this means. This is a live school where this science lab is there. So, when we did the gap analysis in one of the schools that we put this together, the kindergarten teacher came to me and said, all this is great. I'm not teaching pyramids. I'm not teaching light refraction. I'm not teaching anemometer. My problem is, first day in kindergarten school, the child is leaving the parents for the first time and coming into my fold, and the whole world is broken down on their heads. They're all crying. They're carrying their food for lunch. And it's the first time experience. They think the whole world is turned upside down. What can I do? What can you do for me? And ask them, what is your problem? What is that you would like to do? I love to have a situation wherein they climb up the stairs of the class. I love each of the steps that they step through to be playing music that they love to see. And then they'll feel, as I said, the Sunday night experience of watching TV at home becomes the Monday morning experience in the school. Correct? That is the demonstration of how the children themselves. These are all 8th graders in the school who have put this together, and we are now converting this to the steps and the experience the kindergarten should see. So with that, let me stop, and we are available this evening for you to, and we strongly believe the usage of all of these technologies of no use unless it is you put it to use and make it beneficial for you. Thank you. Sairam.
We have already 2 ELCs in working condition, and brother is working on 4 more ELCs for Madurai, one group of schools in Madurai. And typically, one ELC took about 3 months. 3 months. Now we have progressed on the learning curve, so it is much faster. So as brother said, it's a two-way process. It's a demand-based. You as the teachers should come up with your pain points so that we can come out with solutions for that. Thank you for your time.
Thank you so much, Sridhar sir and Balakrishnan sir.